Okay, listener name. So we're diving deep into earthquakes today. You've given us a ton to unpack. Before I even looked at this stuff, I have to admit I thought of earthquakes as like a California thing.
Hmm.
But after seeing what you sent, clearly that's not the whole picture.
Not at all. It's great you're digging into this. Earthquakes, they're one of those things, like we don't really think about them until they happen.
So true. And no predicting earthquakes today, right?
Right. Even scientists can't do that, at least not yet.
Maybe someday. But for now, we arm ourselves with knowledge. And speaking of, this PDF you sent, all about earthquakes. Super interesting. It mentions the Earth's crust being like a giant jigsaw puzzle, always moving.
Yeah, it's a good analogy. Those puzzle pieces, those are the tectonic plates, and where they crack between them, those are faults.
Okay, I'm picturing it.
So, imagine these plates. They're always kind of bumping and grinding against each other, right? And all that does is build up like massive tension.
I see where this is going. So what happens when those pieces just can't take it anymore?
Bam! Earthquake. It's that sudden release of all that pent-up energy, those plates slipping past each other. Think of it like stretching a rubber band way too far, eventually snap.
Ouch. And that's what sends out those, like, shock waves, right?
Exactly. Seismic waves, they ripple out from where the earthquake starts, and it's those waves that make the ground shake. Now, here's something most people don't realize. The Earth's crust, it's always moving, even if we can't feel it. Earthquakes are just, when all that energy is just too much and it lets loose.
Whoa. So we're just living on this, like, constantly moving, shifting planet. No wonder it shakes things up.
That's a great way to put it. And that's exactly why, understanding earthquakes is so important.
Yeah.
So when scientists measure these things, they often talk about magnitude, right? That's the energy that's released.
Right. And this all about earthquakes thing, it mentioned foreshocks and aftershocks too. So it's not always a one and done deal.
Not necessarily. Foreshocks, they're like, think of them as little tremors, maybe. You might feel those before the main earthquake hits. And then you've got aftershocks, which those can go on for, days, weeks, even years sometimes after that first big one.
So even when you think it's over, it might not be over. Okay, that's unsettling.
It's definitely something to be aware of, especially because, like, how much shaking you actually feel. A lot of that depends on how close you are to where the earthquake started, to the epicenter.
Location, location, location,
Mhm.
even for earthquakes.
Ex-
So let's talk about this fault line. You mentioned earlier Utah having a seismic story. And this Wasatch Fault, that seems to be like the main character, right?
Yeah, it's the headliner for sure. And we're not talking about just any fault, you know.
Yeah.
This thing, it's huge. Like, it stretches from Salt Lake City almost all the way to Idaho.
Wow. Okay, so that's a lot of ground to cover.
Right.
And you're not kidding about this whole potential thing. This Utah earthquakes document, it mentions some pretty big earthquakes in Utah's past.
Right, and the Wasatch Fault, it's played a part in some of those for sure. See, Utah, it sits in this seismically active region, right? They call it the Intermountain Seismic Belt, but the Wasatch Fault, that's the one we're really keeping an eye on.
You said earlier, location, location, location with earthquakes. So how does the location of this Wasatch Fault play into all of this? It's not like out in the middle of nowhere, is it?
Nope, definitely not. And that's what makes it so, I don't know, crucial to understand, I guess. Because this fault line, it runs right through some of the most populated areas of Utah. Think Salt Lake City, Ogden, Provo. Like, picture a line drawn straight through those cities. That's the Wasatch Fault.
Okay, so that's setting off some alarm bells for me.
Mm-hmm.
And I'm remembering you mentioned the Salt Lake City earthquake back in 1910. That was the Wasatch Fault too, wasn't it?
It was, and it just goes to show, this fault, it's capable of causing some serious shaking. But even further back, 1934, Utah had its biggest earthquake on record. Happened near Hansel Valley.
That one was a 6.6, right? Which, I mean, that's strong enough to do some real damage.
Absolutely. And the thing is, the Wasatch Fault, it has the potential to generate earthquakes even bigger than that. Like, we could be talking exceeding magnitude 7.0.
Okay, now we're getting into, like, disaster movie territory.
Well, we don't want to scare anyone, but it's definitely something to take seriously. This isn't, science fiction. The geological record, it tells us this fault is active. And, we can't say exactly when, but it's not so much a matter of if we'll see another big earthquake along this fault line, but when.
So, like, within our lifetimes, basically. Not some, geological timescale that's hard to even imagine.
Exactly. This is something that, should be on our radar.
Which is where that whole knowledge is power thing comes in. If we know the risks, then, well, at least we can be more prepared. But what do those risks actually look like? Aside from the obvious, the ground shaking, What else should people be thinking about? Because you mentioned liquefaction earlier, and I got to be honest, that one was new to me.
Sounds kind of sci-fi, doesn't
Yeah.
it? But it's a real thing. Think about trying to build a house on like a giant bowl of Jello. That's kind of what liquefaction is like for buildings.
Okay, I'm trying to wrap my head around that image. So basically, the ground turns to liquid.
Essentially, there are certain types of soil, and if they get saturated with water, like from groundwater, and then they're shaken really violently, they can totally lose their strength. It's like they become a liquid, but just for a little while.
So the ground is shaking. Amy, it's turning to jello.
Yeah.
Not exactly my ideal scenario. You said this is a big concern in Utah, right? What makes it worse there?
Well, for liquefaction to happen, you need the right ingredients, I guess you could say. You need the right type of soil and the right water conditions. Think like loose, sandy soil and a high water table, meaning the groundwater's pretty close to the surface.
Okay.
And guess what? The Wasatch Front, especially the areas near the Great Salt Lake, they've got that kind of setup.
That makes sense. I was reading that liquefaction document you sent, and yeah, it was saying how some areas are just way more prone to this than others. And I mean, having the Wasatch Fault running right through those populated areas probably doesn't help a lot.
You got it. So on the one hand, you've got this fault line that could unleash a major earthquake. And on the other, you've got these areas that are prime for liquefaction. It's, yeah, it's definitely something that has geologists and engineers, paying attention.
Yeah, I could see why. Okay, so we've talked about the science, the risks, but what does it all mean for someone actually living in Utah,
Hmm.
especially near the Wasatch Front? What's the takeaway for you, listener name?
The way I see it, knowledge is power, right? The more you understand earthquakes, the risks in your area specifically, the better prepared you can be, period.
For sure. It's not about being scared. It's about being informed, you know? And maybe having a plan. I'll be honest, after this little deep dive, I'm feeling pretty motivated to go check my emergency kit, make sure it's all updated.
I think that's a great next step for everyone, honestly. And if anyone listening wants to learn more about their location specifically, I always tell people go check out the USGS website. They've got a ton of great resources like hazard maps, preparedness guides, all that good stuff. And it's all tailored to different areas.
Awesome. We'll definitely put a link to that in the show notes. So, listener name, you were clearly already doing your homework on all this. We've covered a lot, from earthquake basics to what makes Utah unique. What's your biggest takeaway?
Well, we've spent a lot of time on the, I don't know, the physical side of earthquakes, the logistics, but it also gets you thinking about the human side of things. Like, how do people who live in earthquake-prone areas, how do they actually live with that risk every day? Does it change how they think about where they live, their work, even raising a family? Makes you think.
That's a really great point. Because it's one thing to understand the science, but it's another thing entirely to wrap your head around what it means to live with that kind of risk. And that's probably a conversation for a whole other episode, honestly. But for now, listener name, thanks for joining us for this deep dive. Stay curious, stay safe, and we'll see you next time.